We are currently running our PhD webinar series, and I am very happy to tell everybody that today we are having our 15th speaker, Dr. Swati Rastogi, with us. Ma'am is from Lucknow, and also our MBSI All India President, Dr. Arvind Deshmukh, is abroad and he is planning to come back today. So Dr. Deshmukh has given his regards. Otherwise, Dr. Arvind Deshmukh is always available in all of our meets. So let me introduce our today's speaker, Dr. Swati Rastogi. Ma'am has done her undergraduate from Lucknow University in 2009, her PG from the same university in 2011, and B.Ed also from Lucknow University in 2014. Ma'am has done her PhD in Baba Saheb Bhimrao Ambedkar University, Lucknow in 2022. Currently, Dr. Swati is working as a senior subject matter expert at OL Expert Private Limited, Lucknow. From 2017 to 19, ma'am has been working as NEET Biology faculty at VIL Education, Lucknow. And earlier than that, ma'am was working as a teacher at Saint Anne Convent School in Lucknow. Dr. Swati has more than 9 national and international publications in various reputed peer-reviewed journals. Ma'am, I welcome you to start your lecture.
Thank you for having me, Jay, and a very warm good morning to everyone. Thank you for inviting me, and I would like to thank MBSI and Arvind sir for giving me this opportunity to showcase my work which I have done. And so I'll start with the title. The title was assessment. I hope the screen is available to everyone.
Yes, ma'am, please. It is available.
The title of my thesis was Assessment of Agro-industrial and Bacterial Surfactant-Based Bioadsorbent Columns for Heavy Metal Removal from Industrial Wastewater. This work has been divided into before I start exactly about the work, I would like to discuss that why did I choose this study. So because we know this increasing industrialization has resulted in generation of various secondary byproducts such as industrial effluents, and that has resulted in giving rise to so many types of toxic pollutants. And our focus was on remediating or removal of heavy metal pollution, and we worked on that. And if we talk about what is the threat because of that, so it is resulting in the biomagnification and causing health hazards in various terrestrials and aquatic habitats. So that's why it becomes a need for the removal or recovery of these heavy metals so that they can be used in other forms as well. So various conventional methods were available, but they have their own side effects and secondary sludge formation, or they are in their own very expensive. So in order to overcome such shortcomings, we investigated this, and the novelty was that we have adapted biosurfactant mediated bioadsorption method for the removal of heavy metals from the wastewater. And we have done two types of study, like we have taken the aqueous system as well, and then we have dealt with the real effluent as well. And if we talk about the objectives we decided for the study, so first was obviously the preparation of the bioadsorbents, and our focus was on to the prepare and screen them should be low cost from different organic waste materials, and then we check their efficiency for the selected bioadsorbents to whether they are able to remove heavy metals in good quantity or not. Then we also isolated and characterized cadmium and lead resistant bacterial stains. So because we have to get a biosurfactant from those, so we checked for those bacteria which were giving good biosurfactant production, and we characterized them at every level. Then we, as I said, we dealt with the industrial effluent, real wastewater. So we did its physical chemical characterization as well. And then we performed in the last the column experiment. So if we talk about how we did the preparation and selection, so we took fruit peels. The final was that we took four organic based materials. I have shown in ahead in the slides, but we worked on two fruit peel waste, that is orange peel waste and banana peel waste. We washed them, dried and crushed them, and then we activated them also. Before that, we acidified them with 5% H2SO4 in a ratio of 3 is to 1, where the this peel waste was in 3 parts and 1% of the acid and was used. Acid was itself in 5% concentration, and then we kept it for 24 hour for incubation, like to let it get sync with the acid. And then we put it in muffle furnace around 700 degrees Celsius. Then we carbonized it. That's how it get activated. So we used chemical method for the activation. We dried it, and then we got in the last these activated carbons from both the fruit peel waste. The other fruit organic waste materials which we took were rice husk and sawdust as well. But when we characterize these materials, and what we found that the we focused on several characteristics for those bioadsorbents, like their surface area and pore volume and pore diameter. So out of those four, rice husk and sawdust and banana peel and orange peel and banana peel were good. So we picked up those two waste materials for our further study. And then we also extracted the biosurfactant from the bacteria. So we performed the liquid extraction method only to get our biosurfactant. And then we also this mixed it with the activated banana peel powder to get it biosurfactant modified activated banana peel powder. These are some of the characterization techniques we perform. First is, as usual, the SEM analysis, SEM EDX analysis. This is done to know about the characteristics of the surface topology of the bioadsorbents, and EDX basically tells us about the elemental composition of the material. So these are done for this, and that for biosurfactant from the surface topology of the this biosurfactant, you can easily check that earlier it was these are the peels, SM micrographs. And then when we modified it with this biosurfactant, you can easily see the difference in the topology and elemental composition. And then we also did FTR analysis, which tells us about the chemical functional groups present on the surface of the bioadsorbents, all the three. Then we also did XRD spectrum analysis that tells us about whether our prepared bioadsorbents are crystalline or amorphous. And then we did the 0 point charge analysis as well. 0 point charge analysis, if we talk about, is basically tells us that the pH point at which that surface will carry neutral charge, zero charge, right? So then we can modify or decide our study that we should go ahead like above that pH or below that pH for the type of pollutant if you want to adhere on its surface. Like if we want to have a plus charge like metals we want to adhere, so we will definitely raise the pH or according to the our surface material. And then we performed our batch adsorption experiment. That batch adsorption simply signifies that we performed our study in conical flasks. We took a particular volume of the concentration, that the metal solution, at different concentrations like 50 ppm, 100 ppm. We started with 5, 10 like this, and then we mixed a required quantity as decided by the SOP, which is also again done by us only to prepare to mix it in the solution, and then we shake it in the and then we put it in a shaker so that proper mixing can takes place. We perform it, and then after that we took out the flask and we assess the metal removal percentage, which is done by the formula that initial concentration minus final concentration upon initial concentration into 100. Final concentration is known by ICP analysis, that is inductive coupled plasma or spectrometry, so which tells us the exact concentration left after the adsorption study. Then also we calculated the adsorption capacity according to this formula, where initial concentration minus final concentration upon the weight of the bioadsorbent which we have added earlier in the study into the volume which you took, like 50 ml study you've done or 100 ml study, like that. So So according to that, we got different graphs at different parameters which we selected the like at pH when we selected. So with orange peel, we found around for lead, like this red is denoting for red concentration, the capacity at pH 4 was found to have 2.5 approx. Then for cadmium ion, it was around 3. So this much is being able to absorb by the adsorbent, that orange peel waste activated one. And then similarly for this activated banana peel, we calculated. So basically the role is to know initial concentration and then final by the ICP analysis. We did this and then we assessed the efficiency of our bioadsorbent, then we calculated the this adsorption capacity. Same different parameter for bioadsorbent dose also we did it for the two peels, and this again for contact time that we chose times like we kept the flask for 30 minutes and then 60, 90, 120, 150, 180, and in this manner we selected this. Then initial metal concentration also we took, we started with 0 as a control only, then 10, 50, 100, 150, 200, like this. So the range is up to us, like how you design your experiment. So from there you get to know about at which concentration, at which amount your adsorption material is capable of extracting uh, metal ions from that particular solution. After that, we also perform desorption studies. Desorption means that now we are checking that at which concentration or how much is the efficiency of the desorpting agent we are using is capable of removing the adsorbed metal ions from the surface of the adsorbent material. So we checked with the two acids and one alkaline solution, that is zero point 0.1 nitric acid, zero point 0.1 HCl and zero point 0.1 normal NaOH also. So we found the desorption efficiency with good with the nitric acid up to 90% for lead and between 80 to 90 for cadmium. And same kind of analysis being found with the banana peel powder also. So nitric acid was found to show good removal efficiency. Then we also assess the regeneration aspect, that how many times the same material can be used for the adsorption study, that how many times you can attach and remove the metal ions. So we found up to 3 cycles it has resulted in good efficiency, and the desorption rate was also found to be good. After that, we performed adsorption isotherm studies also. So for adsorption isotherm study, we used to perform 3 types of studies like Langmuir isotherms, Freundlich, and Temkin isotherms. There are different formulas, and these all are being done on Excel only. And then you put your data, and then you get such graphs. Regression analysis are being done, and regression equations are obtained after that. And Langmuir basically tells us whether it is a monolayer. Freundlich will tell us whether it's a multi-layer adsorption, that is it taking place, aggregation is taking place or what. So according to results, we get to know that in our study, Langmuir adsorption isotherm was found to be good, where adsorption, maximum adsorption capacity was found to be 96.15 and 93.46 for lead and cadmium with activated orange peel. But with the activated banana peel, we found it more, that is 111.11 and 54.05 for lead and cadmium ions respectively. So and regression coefficient value was also found to be close to unity. So if it is closer to unity, then it is said that that model is best suited for that study. So with this data, we came to conclude that Langmuir is more suitable. So that means it is showing a monolayer type of adsorption, so which is found to be good in our study. After that, we also perform kinetic analysis, that at what rate the adsorption study is going in the how the reaction is facilitating. So we perform pseudo first order kinetic model, pseudo second order kinetic model, and interparticle diffusion kinetic model as well. So with that, we got these charts, and then we found that in our study, pseudo second order model was good because the regression coefficient value was closer to the unity, and it was one only in initial concentration was 50, 100, and 50 with this activated at orange peel and banana peel. So that gave us this idea. And then we all, after the batch adsorption experiment, we move on to this isolation of the bacterial strains. So we took around 22 to 23 samples and from different regions of Lucknow only. And after different characterization techniques, that is isolation first and then culturing, subculturing, and then extraction of the biosurfactant, we, as I said in the starting only, that we did liquid extraction experiment. So where we like we took methanol and chloroform for the extraction of the surfactant, and different characteristic gave us this that highlighted ones, that even strain gave a maximum oil displacement activity, then drop collapse activity, penetration assay, the foaming assay, hemolytic assay. These are some of the characteristics being assessed if whether your strain is capable of giving biosurfactant or not. So if the values magnitudes are good for this, then we chose accordingly. We also assess the metal MIC, this is minimum inhibitory concentration of the metals as well. So our strain even was capable of growing in metal as implemented solution or culture media up to 2200 ppm, and for cadmium it was up to 500. And then we have taken another strain F5 also, which was giving 2200 for lead, same as even, but 1000 for cadmium. Later on, we moved ahead with the even only strain because it was showing good characteristics with other properties as well. Like we performed, these are the results for the screening which we done for the strains. Like this is a oil displacement assay. Control will show that the strain, when there is present biosurfactant in the capability by the strain, then it will displace the oil. And then same with this drop collapse assay. This is a collapse drop, and this penetration assay, it will penetrate the hydrophilic surface and will reach to the hydrophobic part. And these are foaming assays and screening hemolytic assays, CTAB assays. These are being performed. Then emulsification assay also we did it. And these are the morphological characterization for the strains we selected. So it was this, and then biochemical analysis. And these are the microscopic and the graphs of the strains. So on molecular characterization, we came to know about that E1 was our Bacillus haynesii strain, and this F5 was Pseudomonas aeruginosa strain. Then for biosurfactant production, we grow our strains in MSM broth, that is mineral salt media broth, where we implemented the strain and we incubated it for 72 hours, where we saw the change that foaming was observed and media color was changed. And then we centrifuged this media, and the supernatant was assumed to have that it will have biosurfactant in it. So we centrifuged that and collected the supernatant, and that supernatant was then acidified overnight with the one normal SCl and kept it in a refrigerator. That will resulted in the precipitation of the all the biosurfactant. And then we performed our chloroform methanol liquid extraction method to extract it. So organic layer will contain the this biosurfactant. So that organic layer after the extraction was collected, and then we dried it in the oven, and rotavapor was also used. And after that we found these are the blackish crystal, blackish sticky appearance of at the bottom of the beaker, the presence of biosurfactant. We scrapped it and collected our biosurfactant. We performed a chemical composition analysis of the biosurfactant as well, whether it is a rhamnolipid type or surfacting lipopeptide type of biosurfactant. So enthroned test, iodine, saponification, glycolipid, different types of tests was performed. And we came to know about after this that even was having this surfacting nature, that is, it is lipopeptide basically made up of lipids and peptides only. And then F5 strain gave rise to rhamnolipid strain having carbohydrate moiety present in them. We also checked the CMC of the extracted biosurfactant critical Michel concentration at this is the concentration which see biosurfactant producing bacteria have the capability to reduce the surface tension. So the CMC will tell us that this is the point at after above which there will be no reduction in the surface tension, that its capacity is this much only in milligram per liter, the biosurfactants capacity. We also performed the stability analysis of the, that is chemical composition stability analysis for biosurfactants extracted in terms of pH, temperature, and salt concentration. And it was capable of showing us good results like ODA capacity, that is oil in terms of results like oil displacement activity, then emulsification activity. These two activities were checked. So our strains were capable of showing good resistance ability at different pH range from 2 to 12 and temperature range of between 30 to 121. We have autoclaved it also, and then that is 121 temperature is indicating, and then different salt concentrations from 2 molar NaCl to 20 molar NaCl, like that. After that, we also characterize our biosurfactants. So for that, we did this FTR spectroscopy. And from there only, then LCMS is more advanced, sophisticated analytical technique to know about the exact composition or the nature of the biosurfactant. So from those profiles, we came to know about that it is a lipopeptide and rhamnolipeptide. Then after that, we did optimization experiments to know the exact like when we were using MSM broth, it's a chemical composition completely, and we were giving a carbon substrate as a glucose. So we wanted to know that because we are using fruit peel waste, they are also organic waste materials. So how much they are capable of giving nutrient as a carbon source to the bacteria to grow and produce biosurfactant. So when we were using glucose as the carbon substrate in MSM broth, so our strains were capable of giving 3.9 gram per liter of biosurfactant. And when we have supplemented it with the orange peel waste as the carbon source, we found almost similar 3.7 gram per liter of the production with the strains, that is with the even strain, because we finally moved ahead with the even strain only. So which was almost having good giving competitive over this glucose. So again, see, these waste materials are abundant, so we can use them as a this for production of the biosurfactant also. So it was a two-way strategy to utilize the our waste material in the form of adsorbent material also as a carbon substrate as well. So bio waste concentration is indicating there. So for optimization, we perform box Becken analysis, CCD analysis only. So it is a mathematical model we applied. So response surface metrology was done, and we got good results with that also. So in that 3D plot, these are the RSM plots we made and got. These are all obtained from the mathematical model only, where the strain was capable of giving good surface reduction ability. Like experimentally, it was 33 dynes per centimeter up to a strain which is capable of reducing surface tension, like MSM broth has a surface tension of 72 dynes per centimeter, and this strain was capable of reducing it up to 33, and with our glucose substrate it was reducing it up to 28. So it was almost competent to use it, this organic peel waste, as a carbon substrate. Then we checked the lead resistant capability. So these strains were grown at different lead concentrations, starting with the 102 till 2200. Then we checked the ability of strains to emulsify their emulsification index also at different concentrations of lead. So these are the charts which are indicating the results. Then the mechanism of bioabsorption study was also analyzed. That first over A figure is indicating the natural morphology of the strains and micrograph and the elemental compositions, which are EDX analysis simply. But after the absorption of lead, you can see white depositions which are lead only. And in the EDX also, we get to know about the peak of lead. So these are the mechanism which indicated that on the type of mechanism, if we want to indicate, so it will be ion exchange, complexation, and precipitation, or it's an integrated mechanism that has resulted in deposition or adsorption of the lead metal ion on the surface of the bacterial strain. So they were capable of, so it was actually to know that whether our strains itself are capable of extracting or removing the metal ions from the solution. So they are using it for their growth also. They optimize their machinery, internal physiology to grow in that concentration, and they were absorbing it also. So that is also the study we analyzed in our during whole study. Then in the last, we move ahead with the physical chemical characterization of the effluents. And the glass column was taken. It's a general representation where we put our influent, that is metal infested water, in the separating funnel. Then it was attached to the glass column, and the glass loaded bioadsorbent influent solution was mixed. These blacks are representing our column filled with the bioadsorbent material, that is biosurfactant modified one. And then it was a downstream process because we were giving influent from the top. So we collected the, after letting it stay in the column for some time, the clear effluent, that is filtered water. And breakthrough curves were analyzed for these after different study. And these were also done for different parameters, like for contact time, then at different lead concentrations, like flow rate was in performing breakthrough curve analysis. We took three parameters, that is flow rate, that at what rate we are allowing the metal to, or the solution to come into the column, that is flow rate at 50 ml per and 20 ml per minute. We checked it for both metal ions. And then we also assess the height of the column, that is how much up to which this uh, adsorbent material will be filled, like 2 centimeter and 4 centimeter. Height is this much only because we got biosurfactant up to 3.9 grams and that much. So, and because of that, this much height is only taken. But it is advised that after performing this one different experiment, that it is it would, you can take different parameters of the height as well. The more the height, more, but not that much high. Then different concentrations also we took, like 50 ppm and 100 ppm of this 50, 100 or 100 was the optimized condition we got in batch adsorption. That's why 100 was taken, and one another different to check the condition. That's why 50 then was taken. So through breakthrough curve analysis, we got to know that for lead and that, so different flow rate and different bed height and different initial concentration give us the insight that if the flow rate is high, if the bed height is high, and if the this initial concentration up to 100, which was optimized in our batch X condition also, so our this biosurfactant modified bioadsorbent material was able to give good results. So percentage adsorption was almost 87, 78, 80, 91. So the one which is having higher was the best condition. After that, we applied Thomas model for this. Although this model was not applicable for the our study, it doesn't fit for our study, and we wanted to check it. That's why we performed it also. So adsorption models are only here to indicate, but because we cannot rely with these models so particularly, because different experiments are performed with different conditions. So that's why we get different results for that. And it's not necessary that it will always, these models will always correlate with your study. So these are the evaluation values which we got, where because the values adsorption capacities were very less, so from there we indicated this model was not for fit for this type of parameters which we selected. So after that, we moved ahead with the column study for the real wastewater effluent. For that, we got breakthrough curves in this manner, and the maximum percentage which we got, yeah. So the maximum percentage of adsorption which we got was with real wastewater, 92 for lead and 92 same for lead and cadmium. A small difference was only there, and the maximum adsorption capacity was 28.57, 8.76. Initial concentrations were for lead it was 20.86 ppm, but with lead it was 6.39 only. So this much of the concentration we had found in our real wastewater from a electroplating effluent. These are some other parameters before treatment. We checked for the electroplating effluent, and after treatment, we got to have reduction in most of the parameters in good amount after performing this study. So this was the final step, and we got good results with that. So these are some of my publications which I have published during whole course of my study. And some of the conferences, workshops that I have attended. Thank you.
Thank you very much, ma'am. It was a presentation. Now we are open for question and answers. So anybody who might have questions, please unmute yourself, turn on the camera, and you may ask the question.
Very good morning, ma'am. Very nice presentation.
Thank you.
Your work is very much valuable in the field of applied biotechnology and the field of applied microbiology. So there is one question I would like to ask, ma'am. What is the percentage of reduction as compared to biosurfactant with and without bioadsorption methods you have used?
Yes, with the when we were performing this, because we have used not used biosurfactant with batch study. So exact result we cannot give you because we used biosurfactant in the end only to modify the bioadsorbent. And when we used it, so because it won't be wise to say that it's for this because we haven't checked in batch, no. So I won't be able to give particular value answer for that. So, because we have used in the last only. But with the if we compare simple with column and batch without biosurfactant, so we do got good results when we were performing column experiments.
And what type of the biosurfactant you use? Like the biosurfactant, according to the low and molecular weight compounds, we classify them under different categories. So actually, which biosurfactant was?
It was yes, it was surfactant.
Okay.
From Bacillus heinesi.
Yeah. Okay. I'm feeling very nice to share, ma'am. I am also working on a biosurfactant.
Okay.
And I'm also working on various applications.
Yes,
maybe in future I will get back to you. So if time permits, we can think for any kind of the collaboration.
Definitely, ma'am. Definitely.
Yes. Basically, I'm in MIT WPU, ma'am. I
Okay,
will contact you, ma'am. If possible, can you please post your email ID or and contact number also?
I'll write in the chat section. Okay, ma'am. Sure.
Okay. Thank you so much, ma'am.
Thank you, ma'am. Thank you.
Thank you, Sikha ma'am. Do we have any more questions, audience? Kindly unmute yourself and you may ask a question. And also you can use chat box if you want. Okay, very nice, Swati ma'am. You have posted your email ID in the chat box. Swati ma'am, I have a question myself.
Yes.
I would like you to, I would like to ask that what were kind of difficulties you faced while doing your PhD work? Since we have many students here, I think we can benefit from that answer.
Yeah, right. We do faced a lot of difficulties, in terms of arranging the resources to perform the study. First of all, it's a condition like for every. I will be very honest. Like in all the university, we will face such difficulties where you have to collect media from one lab to other lab. So do maintain your contacts. That would be suggestion from every student who is going to enter, and in this manner. And then when you are performing these you will find that we have seen that our experiment has failed many times because of environmental conditions. Then sometimes instrument doesn't work. So you should not let it be let it come on your head that, oh, it is failing, so we won't be able to do, and that's how you get frustration, and that's what you have to overcome during those times. And we all, since it was COVID time also, I completed in 2022, so 1.5 year was lost. We were not able to go in laboratory, our strains were not subcultured, and somehow when it got opened, we got to we immediately went and we subcultured. That's how we preserved our cultures also. And although we had preserved them in glycerol, but we have observed that strains do lose their property. So we need to, you have to definitely keep on subculturing them to preserve, and do check after some, keep different time intervals, that whether they are able to give a different same results or not. So that's what I would like to give advice to all the students who are going to enter into this field in terms of research.
Thank you very much, ma'am.
Ma'am, can I ask one more question from you?
Yes, ma'am.
Yes, I just want to know, you have used also chitosan as a absorbent. So
Mhm.
basically, how you can compare that it is a more promising agent that will enhance the activity of biosurfactants?
Because we have acidified it, no. So although all the waxy material were already were being dissolved, so we were not able, but like it was didn't interfere much with our further study, because most of the things were already on acidification. We will lose it, all the high molecular mass hydrocarbons, that like basically the waxy materials which are present with these. So that will, I don't think, will interfere much.
Because chitosan itself has some kind of the antimicrobial activity. So
Yes,
when
yes.
you are using it with the biosurfactant, so that possibility is not there that it will show some kind of the antimicrobial action.
Because we didn't checked it, no. So I won't be able to answer that, whether they were interfering or with, because we were focusing on one parameter, that is how much it is absorbing, and antimicrobial and so antimicrobial strains activity we have checked, but with the whether the strain, that material is, that we didn't check.
Okay, thank you so much, ma'am, for answering.
Okay, ma'am. Thank you.
Thank you, ma'am. Swati ma'am, after your PhD was completed, how are you preserving your strains?
My juniors are there, so they are subculturing it and using it for further, because we have planned for further also, like we want to go at nano level as well, and wanted to check. So we have our juniors at laboratory, so they are doing.
Great. I would also like to suggest that you should preserve your strains at culture collection centers.
Yes, we have done that. Yes.
Great.
You can preserve, madam, strains in glycerol at -80 also.
Okay, madam. Yes, sir.
Subculturing is okay, but long-term preservation can be done in glycerol
Yes, sir.
at
Yes, sir.
-80 or -196 under
We have
nitrogen.
done that during COVID time in glycerol, sir. Yes, sir.
The subculturing may lose the property,
Yes,
frequent
sir.
subculture.
Yes, sir.
But in some strains, you gain the properties like mycobacterium. We have used one Russian strain. So
Okay.
frequent subculturing is required. At least 50 subculturing is required.
Mm.
Yeah.
Yes.
That is true, Vinay sir.
Yeah.
Thank you.
Your good name, sir?
Myself, Jay. I am from capital city of Gujarat. I am working as a research scientist there.
Where do you work?
I work at Prerna Bioinnovations. It's a small-time CRO firm.
Okay. Jai Gujarat, no? Jai.
Yeah. I am from Gujarat, Gandhinagar.
Okay. I stayed there at Baroda.
Okay, nice. Right.
Sterling Biotech.
Okay. Nice, sir.
Yeah.
Do we have any more questions? Anybody? So I would like to mention one more thing. In this our PhD webinar series, we are giving mementos and certificates to each speaker. So Swati ma'am, we will also be sending you memento in 1 month's time, and we
Okay.
will issue the certificate immediately.
Sure, sir. Sure.
Thank you.
Thank you.
And as in the chat box, Swati ma'am has already mentioned her email ID. So if anyone has any further questions, you can just mail Swati ma'am. And see you all on next Sunday. Thank you very much, ma'am.
Thank you, sir. Thank you.
Okay. Thank you. Prathamesh, you can end the lecture now. Thank you.